Hi, this is Dr. Bitla. Today's session, we will discuss the introduction to CAM and CAPP. In the last session, we have discussed introduction to the communication networks, in which we have seen local area network, metropolitan area network, wide area network, wireless network. The topologies of the local area network we have seen, like bus type, ring type, star type, the advantages, disadvantages of the local area network also we have seen. Basically, this LAN is used for the restricted areas to connect different systems, to keep different systems in connected together in network. Metropolitan area network is used to connect the systems in a town. This network is if you have a town in which you have different systems, if you want to keep the systems in a town, the range is around 50 to 60 kilometers. In that case, we use this type of network. This can be termed as MAN. Then when you come to the wide area network, this wide area network is going to connect the systems, maybe the states, maybe the countries, maybe the continents. This wide area network is some extent slow. The systems are connected using the satellites in this case. So the region, I mean the area to connect or to area to keep the systems in network is maybe states, maybe countries, maybe continents. So we are calling this as a wide area network. Then you have a wireless network. In this case, the companies or firms are going to design one device. That device is going to emit the signals. Those signals are received by the network systems. The systems which are in this network is going to receive those signals to connect or to keep those systems in that network. So these four types of networks were discussed in the last session as a computer aided design and computer aided mechanical manufacturing engineer must be able to know all these network types as the design engineers or the manufacturing engineers need to work in the communication networks. Oh, so this type of all these four types are discussed in detail in the last class. The objectives of today's session is to introduce what is CAM. We will discuss in detail the overview of the CAM. Then we will move forward. We will discuss the information flow in a CAM, in CAM using a flow chart, how the information is flowing in the case of computer aided manufacturing system. The basic steps and the important steps involved in a computer aided manufacturing system we will see with this diagram. Then we will move forward to see the need of CAM, what exactly the need to implement CAM we will discuss. Then we will see the functions of the CAM. What are the functions this when you implement CAM, what it is going to function, I mean how it is going to function. There are different functionalities the manufacturing system, computer aided manufacturing system needs to perform. Then we will see the stages of CAM. What are the different stages involved in implementing CAM? Those steps we will see in the coming slides. Then we will see the different benefits when we implement CAM. What are the benefits that we are going to get? That also we will see in this slideshow. Then we will move forward to discuss regarding the computer aided process planning. We will define the process planning. Then we will see the different steps involved while implementing computer aided process planning. Those steps also we will see in this slideshow. Then we will see the structure of computer-aided software, what exactly the structure, what are the parameters, what is the database we need to keep to implement computer-aided process planning, that we will see using one typical diagram. Then we will move forward to discuss functions of computer-aided process planning. If you implement CAM, if you implement computer-aided process planning, what it is going to, how it is going to function, and how many functions it is going to perform, that we will see. Then finally, we will see the advantages and disadvantages when you implement computer-aided process planning. Those also we will discuss in this slideshow. When you come to the introduction to the CAM, CAM stands for computer-aided manufacturing, usually works along with the computer-aided design process. Uh, Normally, design process takes place first and foremost step in any of the production is the design process. After designing, we will come to the manufacturing. In between that, we have process planning. Of course, the computer aided manufacturing is going to, CAM is going to work along with the uh, CAD CAD to integrate. So we have the computer aided process planning in between CAD and CAM. Computer aided manufacturing is the use of software. I mean, CAM is going to use a software and computer controlled machinery to automate the manufacturing process. CAM is going to use a software to control the machinery to automate the manufacturing process. In turn, we can define in that way. You have another definition to the CAM. CAM is also, of course, it is a software to manage, plan, and control all the operations involved in the manufacturing process, either by interacting directly or indirectly with the resources available in the manufacturing process. Once again, I will try to define. The CAM is defined as the use of computer systems. We are going to use the computer systems to plan, to manage, and control the operations of the manufacturing plant. A manufacturing plant is having number of operations. Those operations are controlled and managed or planned using the computer systems by interacting with the resources available in the manufacturing process. The interaction may be direct or maybe indirect interaction. This is exactly the typical flow chart of computer aided manufacturing system. Uh, the moment we design, uh, we will have a geometrical model. So that CAD computer aided design model is going to integrate it with the CAM process. So CAD software or the CAD model is integrated with the CAM system. CAM CAM system in turn, which reads all the geometrical 3D geometry data by scanning the diagram or inbuilt. This is the inbuilt process. This CAM software is going to scan the 3D model generated during the design process. After reading that, after reading the 3D model by the CAM system, it is going to generate one geometrical file. This geometrical file consists all the information, boundary information or the design information related to that CAD model. This geometrical files, once again, I will tell you, these geometrical files are going to carry all the information related to the design, which involves the boundary rep information, which may be the theories of failure information, design information. All those will be carried by this geometry file. By taking this geometry file, the information available in this geometry file is used for the process planning. In this case, tool is selected, sequence of operations are calculated or identified. So you have a design, that design model or the geometry model consists the number of features on that. Feature means the operations that are to be performed on the workpiece. Feature is, in turn, you can also define feature is the region uh, to be focused with respect to the manufacturing. For example, you have a raw component on which you need to produce the, you may need to produce the holes, slots, blind holes, like that. So these are called the features of the component. Hole is a feature, slot is a feature, then you have other types of blind hole is also a feature. Like this, you have the features on the features we need to produce on the component. But while performing those features, we need to identify what we need to first, what we need to perform later. The order is also very, very important. What should be performed first, and what should be performed next, and what should be performed further. So that we need to identify the sequence of operations to be performed on the component or to produce the final component needs to be sorted out or needs to be listed out during this process. In turn, we can call this process as a process planning. You have design process, and finally you have manufacturing. In between that, you have process planning. During this stage, as I said just now, the sequence of operations to be performed on the component needs to be sorted out, needs to be listed out. Then during this stage also, we need to identify the type of machine to be used, and type of tool to be used, and machining parameters like the speed, feed, and depth of cut that we need to use with respect to the material, or with respect to the machine, or with respect to the type of tool. These parameters varies. All these machining parameters, sequence of operation, will be identified during this stage, that is also called as process planning stage, using the processing data. By processing the data, process planning will be performed. To perform the process planning, we require some data. By taking the data, process planning will be performed. So after completing the process planning, then we will process that by simulating the data. You after process planning, the next step is next step is to generate the programs, NC programs. If you use a CNC machine, we need to program, we need to code as per the geometry of the workpiece. So after coding, after by using the data of computer aided process planning, we code as per the features on the component, as per the features that we need to produce on the component. That code fed into the machine before that. So by generating the program, by writing the NC program, using that NC program, the component is simulated first. So before going to the actual manufacturing, this code is simulated, whether the operations, whether the code is correct or wrong, whether the operations are performing practically or as per the code written, or as per the requirement, whether it is producing the actual component or not. If there is any error, again we will come back and we will modify the errors. So the simulation is very, very important before going to the actual manufacturing. That simulation is performed before feeding this program into the actual CNC machine. So the moment we integrate this CNC program, the moment we feed this NC program into the CNC machine, this CNC machine is going to perform all the actual operations to produce the final component. So once again, we will see the typical information flow in this CAM system. The 3D model will be the input to the CAM system. 3D model will be the input to the CAM system, which is the 3D geometry of the component will be read by the scanning. By scanning the 3D geometry, this CAM system is going to read the geometry. As per that, one geometry file is generated. So using this geometry file, process planning will be performed. During this stage, sequence of operations to be performed, or sequence are listed out to move further. In this stage, machining parameters is also identified, like speed, feed, and depth of cut, using by processing the data of the geometry file. Then, after completing the process planning, the programs NC code programs are written. Before feeding these programs into the CNC machine, simulation will be performed. So during the simulation, we come to know whether the operations are performing perfectly or not, accurately or not. Then we can visualize on the screen. uh, the moment we satisfied with the simulation part, then we will go for the actual manufacturing process using CNC machine tool. This is the typical flowchart of CAM system and its working and its information flow. Then we will move forward to discuss the CAM. Uh, as we are already discussed that process planning, 3D model, then we have NC coding, then that will be simulated. The moment we satisfy with the simulation part, then that those programs are fed into the CNC machine to produce the final product. This we have already seen, discussed in the flow diagram. When it comes to the need of the CAM, when you implement CAM, we have the benefits, or we have actually, this is the need. Why do we need to implement the CAM? Means to increase the productivity. So to increase the productivity, we need to implement the CAM. To reduce the labor cost, we need to implement the CAM. To improve the workers' safety, this also improves the product quality. And to get the dimensional and material consistency precise, means accurately we will get the components. The component dimensions are precise in its nature, and the material is consistency we have with respect to the material. Then when you implement CAM, this is also one of the need of the CAM. The amount of raw material required also reduces, so that this when you implement CAM, it also minimizes the wastage of the raw material. It also reduces the energy consumption. When you implement CAM, it is going to reduce the consumption of the electricity. In turn, it also reduces the cost of the product. Once again, I will try to list out: productivity increases, reduces the labor cost, improves the worker safety, improves the product quality, closer dimensional tolerances we will get, then reduces the amount of raw material wastage, then reduces the energy consumption when you implement CAM. So these are all the needs of the CAM. To implement CAM, these are all the requirements. Whenever you want to implement CAM, you need to keep all these points in our mind. In turn, we can say that CAM is going to fulfill all these activities. When you come to the functions of the CAM is basically, it is going to the functions of the CAM are basically divided into two categories. One is manufacturing planning, and the other one is manufacturing control. In the case of manufacturing planning process, in the case of manufacturing planning process, CAM is going to work offline. In offline, that means the computers are integrated to the machines, computer aided machines integrated. The machines as well as the computers are integrated together offline. Offline means there is no, I mean, we have communication between machine and CAM, but we have only one directional flow of the mission. That means one direction flow of the information. That means computers, in this case, the computers are going to observe the process, and those computers are going to collect the data from the process. That's all. It is the computers which are integrated with the mission are going to observe the process. Along with that, the computers are going to collect the data from the process. Up to that only the computers are used. Hence, in this case, in the case of manufacturing planning process, there is only one directional flow of data. These are only used to monitor the data, but it is not used to control. As you can observe that functionality in this figure, computer, here you have computer and process. In this case, the computer is going to monitor the process. It receives the data from the process. It receives the process data, but it is not going to supply, or it is not going to give any feedback signal, or it is not going to give any signal, or it is not going to process any data in the computer, and it is not going to send the processed data to the actual process. Hence, you can say that it's only monitoring. Computers in this case are used for only monitoring the process. It is not going to control. Then when you come to the other type of process, that is manufacturing control process. In the case of manufacturing control process, we will discuss this control process, but when it comes to the functions of the manufacturing planning process, there are some functions this manufacturing planning is going to perform. So that is, it is going to perform the process planning, computer aided process planning. It is going to process the data. As we have seen, only we have one directional process. Then it is going to it is going to generate the NC code programming. Of course, it is also one directional. Then computerized machinability data systems. Of course, the system, there are some types of systems which are going to assess the machinability. Then there are some types of systems which are going to standardize the works. Then there are certain types of systems which are integrated to the machine to estimate the cost. So in all these activities, so computers are involved just to monitor and process the data. Those are just receiving the data, and it is doing some work, but it is not sending any signal. It is not controlling anything on the mission. I mean, the machines are, I mean, these computers are not going to send any information in reverse direction to control the mission. In turn, we can say like that. Then you have, the other function of the manufacturing planning is production and inventory planning. It is also see the production, how the production is doing, and it is also looking the inventory. It is also planning the inventory. You are aware that inventory means how much buffer stock is maintained in the firm or in the company. This is also perform that function. Then line balancing is also very important functionality of the manufacturing planning. How the material is moving from one location to another location. This computers is also going to look into that data. Then you have other function of the CAM, that is manufacturing control. As we have seen in this case, we have a figure here, the second functionality, manufacturing control functionality. In this case, the computers are integrated to the machines or the process. In this case, the computer is going to receive the data. After receiving the data, process data, this computer is going to process the data. According to that, this computer is going to send the processor the data to control the process as well as the machine. In this case, the computer is going to use the process, control the process of the machine, control the process or the machine. As you can observe with this figure, so in this case, the data flow is two-dimensional. You can see this computer is receiving the data as well as sending the data after processing based on the parameters, receiving the data. Assume that you have one process boiler. Assume you take one boiler. That boiler is designed to withstand 100 bar. Assume that that boiler is designed to withstand 100 bar. If this computer is going to read the 100 bar data, the moment the pressure in the boiler exceeds the 100 bar, this computer is going to operate the exhaust valve or the feed check valve to control the process. Like that, it is going to send signal to control the process or to control the machine. This functionality is, as you can see, this in this case, the data is flowing in two-dimensional. When you come to the functions of the manufacturing control, it is going to process the monitoring and control. It is going to process as well as process. It is going to monitor the process as well as the control. The process can be anything. The process can be anything. The computers are going to process the data as well as by sending signal, the computers are going to control the process. In this case, the computers are performing two functions. One is monitoring, and it is also going to process to control the process. Then you have the quality control. These, I mean, the computers in this case are going to assess the quality. Based on that, it takes the decision. Computer is going to take the decision. It will send some data to control the quality. Then these computers are also this type of controlling system, or this type of functionality is also going to control the shop floor. Controlling shop floor is very important activity in any of the firm. Optimizing the shop floor use, I mean, optimized usage of the shop floor is very important in any of the manufacturing industry. So that also, this this is also one of the functionality of the manufacturing control. It is also control the inventory, up to what extent the buffer stock needs to be maintained. It may be a raw material or it may be a finished product. So this is also one of the functionality of the manufacturing control. Then the production systems, it is also going to control the production systems. It is also going to control the CNC machines. This is also one of the functionality. Then you have the machine tool control. This, I mean, the computers are also going to control the machine tool. With the speed of the spindle, you take one machine, you take one lathe machine or a turning machine. If the speed of the machine exceeds the rated value, the computer is going to send some signal to reduce the speed of the spindle. So this is also one of the functionality of the manufacturing control system. Then we have the stages of the CAM. There are different steps involved in CAM. The first step is to identify the geometry errors. The moment you design a component, it might have some errors. Those errors must be identified before sending the geometry, before sending the 3D component into the manufacturing or the CAM side. The errors needs to be identified. So if there are any errors, the geometry can send back to the 3D modeling software or the design software. It should be rectified. Then we will take back that model to integrate that model with the manufacturing system or with the CAM. Then identifying the process and missions. So as per the 3D model, so we need to identify what process we need to use to manufacture that product. There are different manufacturing methods to manufacture the component. It may be a machining, it may be a casting process, or any other forming process. There are different manufacturing process. Uh, before integrating, that, after identifying the errors from the geometry, we need to identify the process to manufacture the component. Suppose if after identifying the process, suppose you are identified, you are chosen the machining process to manufacture the component. So if you are chosen a machining process, right, so you have to choose what machine you have to incorporate, or what machine you have to use to produce, or the machine that component, maybe turning machine, maybe milling machine, maybe drilling machine. You have to identify the missions required. Might be, it may not be one mission. Sometimes you require number of missions. We have to identify the missions required in this stage. The first stage is identify the errors. If you find any errors, send back that model to the design software or the design side. Then after rectifying the errors, we will bring back that model. After that, we identify the process, what process we need to use to manufacture that component. Then we have to identify the missions required. After this step, we need to identify the fixtures required, fixtures, jigs and fixtures required. So you are aware that the different types of jigs and fixtures are available. We have to identify as per the geometry and the topology of the component. We need to choose the fixtures. Then we have to identify the setups also. In what way we have to fix the workpiece on the work table. According to that, we have to select the fixtures. Then we have to identify, we have to list out the operation sequence. What process we need to start first. Example, first you may do drilling process, then you may do milling process, then you may do the turning process. So those type of operations needs to be sorted out or needs to be listed out sequentially. So after that, then the machining features, I mean, as per the features to be performed on the raw component, the sequence needs to be listed out. The sequence needs to be sorted out. Then we will then we will identify the tools used as per the accuracy required, as per the surface roughness value we need to produce. Based on that, we have to select the cutting tools. Then we have to select the cutting parameters also. As I said just now, during the typical CAM cycle, during this process, we need to identify the cutting parameters like the speed, feed, and depth of cut, according to the type of machine used, according to the material we are machining. So based on that, we have to identify, we have to select the cutting parameters. After that, we have to generate the code. We have to generate the code, G code and M code. After that, we have to generate the path. So after generating or after writing the G code and M code or NC programming, we will simulate that and we are going to generate the tool path. NC programming will be performed using G code and M codes, CNC programming, computer numerically controlled programming, or numerical control programming. Uh, that coding is frequently used, generally used in any of the CNC machining side. After after generating the code, that will be simulated before sending the component to the actual manufacturing. That will be simulated first. The moment we satisfy with the simulation or with the uh, tool path, we can send or we can integrate that code with the actual machines, actual CNC machine. So these are all the stages of the CAM. These are very, very important stages. In any of the computer aided manufacturing system must follow these steps. When it comes to the benefits of the CAM, there are lot of benefits. There are a lot of benefits when we implement CAM. It is going to reduce lead time. It is going to reduce the inventory. Then it is going to reduce the setup time, machine time, direct and indirect labor cost. So these are all the very, very important benefits that we get when we implement CAM. Lead time means the actual time to the expected time, the difference between actual time and expected time. Always the actual time is more than the expected time. So that is going to be reduced when you implement CAM. Inventory reduces how much buffer stock we need to maintain. When you maintain more buffer stock, that is also the waste of money. So we need to maintain the optimized level of inventory. If you keep more stock also, that is also the waste of money. Maybe in the form of material, we need to spend amount of money to purchase the raw material. If you keep more amount of raw material in the form of more amount of raw material, that is also the waste of money. It also reduces the setup time. Then it also reduces the direct and indirect labor cost also. Then more efficient to use factory warehouse space. When you implement CAM, it is going to optimize the use of warehouse space, factory and warehouse space. That means economically, I mean, it's going to optimize the usage of space in the case of warehouse, where we are storing all the goods, finished goods, as well as the where we are storing the finished goods is nothing but the warehouse. Then when we implement CAM, factory layout is also optimized. I mean, optimized manner we are going to accommodate the machines when you use the CAM. When it comes to the other development, this CAM is going to standardize the works using the software packages available. Computer-aided manufacturing is going to use the software. CAM is going to use the software where you have different softwares. Using those softwares, work will be standardized. This is also one of the advantage of the or the benefit of the CAM. Then it is going to estimate the cost of the new product. Of course, we have a old product, then it is not necessary. Whenever you are manufacturing a new component, this CAM is going to simplify the estimating, simplify the task of estimating the new product cost. It is going to simplify the estimation of the new product cost. This is also one of the advantage. Then you have many operations can be performed in a single machine. If you implement CAM, the other advantage is that the computer aided manufacturing machine or NC machine or CNC machines are normally used in the case of when you implement computer aided manufacturing. So a single machine is going to perform number of operations, so that the movement of the raw material from one shop to another shop reduces, in turn reduces the wastage of time. In turn, it also reduces the cost of the product. Then it also different parts can be produced on a single machine, because one machine is going to perform number of operations, so that we can produce number of parts on a single machine. This is also one of the very important advantage of the computer aided manufacturing system. Then quick and easy implementation of the design modification. Suppose you have one existing design. If you want to change or if you want to modify the design, when you implement CAM, this really going to help us to meet the changes of the modification of the existing design. That means easily you can modify the existing design to manufacture a new component with the modifications. So this is also one of the very important benefit of the CAM. Easily you can meet the requirements of the customer. You can change the design as per the needs of the customer. This is also one of the advantage. Then it is very quick. It is, I mean, within a less span of time, you can produce the product, produce the very complex surfaces. When you implement CAM, very complicated shops components can be produced very easily, hassle-free, means without any difficulty. You can produce the complicated shapes within a quick time. That is what he's trying to say. Then drastic time reduction, it is obvious, because we are programming NC programming that is integrated with the machine. There is no manual intervention, so that the time reduction, the production time reduces. CAD and CAM is going to standardize the implementation. Of course, when you use CAD CAM, implementation of the CAD CAM will be standardized when you implement the CAM. This is also one of the benefit of the CAM. When you implement CAD and CAM, almost CAD and CAM are going to use the softwares which are going to use the computers or computing machines. So the visualization is more. The modeling and testing will also be more. So visual representation and integration of modeling and testing is one of the best application when you implement CAM. When you implement CAM, you have other advantage, that is can automate the creation of performance report automatically. When you implement CAM, the other benefit of the CAM is automatically this CAM is going to generate the performance reports, because we are integrating everything with the computing machines or computers. It is going to generate the reports automatically. Then you have other important topic, that is computer aided process planning. Briefly, I told with you in the previous slides, computer aided process planning. Uh, oh, this is mainly concerned with finding the sequence of individual machining operations required to transform raw material into the finished goods. Individual manufacturing operations required. Basically, the major step in computer-aided process planning is to sort out the steps required to perform or to transform the raw material into the finished goods. What are the steps required to transform raw material into the finished goods? So this computer-aided process planning is going to do that major step. Operation sequence, this computer aided process planning CAP is going to document all these operations on a separate sheet. In turn, that is also called as operation sheet. The objective of this operation sheet is to document all the operations, right, as well as the machine tools used for a work part and assembly. Then it is also going to document the tooling like jigs, fixtures, and special tools required to transform raw material into the finished goods. This is also one of the advantage or one of the benefit of the operation sheet. Operation sheet is going to document the operations as well as the machine tools required for a work part or an assembly. It is also going to document tooling required like jigs, fixtures, special tools that can be used to transform raw material into the finished goods. When it comes to the definition of the computer-aided process planning, systematically determination of systematic determination of detailed methods, systematic determination of detailed methods by which the workpieces or parts can be manufactured economically and competitively to transform the raw material to the finished goods, or from the initial stages to the finished goods. I repeat this definition once again: systematic determination of detailed methods by which the workpieces of parts can be manufactured economically or competitively. Economically means the cost of the product should be low, as well as it should meet the requirements of the customer. It should be able to sustain in the market by fulfilling the needs of the customer in an efficient manner. Systematic determination of detailed methods by which the workpieces of parts can be manufactured economically and competitively. There are two different approaches in CAP. One is variant approach, other one is generative approach. In the case of variant approach, this variant approach is used to modify the existing process plans. It will look for in this variant approach. Suppose if you want to generate one process plan, in this approach, it is going to look for the similar process sheets that you have. It will look for the part families, similar part families or the codes. It will retrieve some process plan from the database or from the computer, and some data or some steps automatically suits. If a part belongs to the same part family, maybe its geometry is same, its topology is same. In the case of variant approach, it is going to pick one process planning from the database, and it will modify, it will edit as per the needs of the new component. In the case of variant approach, existing process plan is modified as per the needs of the component to be manufactured. We have some database there. You have all the process plans from which we will pick up which suits to the requirement of your component as per the topology, as per the geometry of the component. Then you have the generative approach. In this case, a completely new process plan will be generated or created for your component. These two are the important approaches frequently used in the case of computer-aided process planning. We have steps in computer-aided process planning. The first step is the selection of the process and tools. Obvious, first you have to select the process and tools. Then you move forward to select the machines and manufacturing equipment. Then you move forward sequencing the operations. As we are already said that sequence of operations are very important step in the case of computer-aided process planning. When you discuss something about CAPP, means you need to say this single word sequence of operations is the key step in computer-aided process planning. Then group all those operations according to that. Select the group all those operations according to that. You choose the missions, you choose the layout. You are going to, as per the operations to be performed, we are going to send the raw component to the machine shop. Machine shop means if you have drilling operation and boring operation at one place, means we are going to send the drilling shop. So there all the drilling and boring operations are performed. After that, we will send the component to the another machine shop. So the grouping of operations is useful in that aspect. Then the selection of the workpiece holding devices, jigs, fixtures are very important. How to hold and how to guide the tool is very important aspect in any of the manufacturing process. So based on the topology or the geometry of the workpiece, we need to select the jigs and fixtures or the other tools required to hold the workpiece. So these are the important steps performed in computer-aided process planning. Select the process and tools, then you select the machine tools and manufacturing equipment as per the process, then list out the sequence of operations, then you group the operations. As per that, we are going to send the raw component into the different types of machine shops. Then you select the workpiece holding devices as per the topology of the workpiece. So these are all the steps everybody needs to follow in the case of the computer-aided process planning. Then you have other step, the select the inspection instruments. So after production, we have to inspect the component whether the dimensions of the component is meeting as per the needs of the customer or not. We have to select the inspection instruments also. That is also one of the important step in the case of CAPP. Then determine the production tolerances, or find out the tolerances. Tolerances are also very important. Up to what range of tolerance is acceptable by the customer, that tolerance limit will be supplied by the customer. As per his needs, we have to decide the tolerances. Okay. Then determine the proper cutting conditions. Find out the proper cutting conditions, whether you have to perform the operation using a coolant, or sometimes you may need to perform the machining operation in air conditioning environment. You have to select. If the accuracy is more, in that case you may choose the condition also, at which temperature you need to perform the operation, because as per the temperature also you have thermal expansion and contraction coefficient. We need to select the condition at which temperature we need to perform the machining. That is also very important step in the case of computer-aided process planning. Then calculate the cutting times and non-machining times. This is also required in the case of computer-aided process planning. Then finally, if you find any errors in the sheet, then you edit the process sheet as per your requirement. Then we will discuss the structure of the computer-aided software. This computer-aided process planning software is having two basic modules, module 1 and module 2. This module 1 and module 2 is integrated with the display unit, obvious to see or to monitor what we are performing with the software. This module 1 is going to list out all the sequence of steps performed in CAPP, as we have seen just now. So these sequence of steps may not be in order as per the requirement. We can change this order in module 1. Then this sequence of operations, or each step, is going to integrate with the database. Backend, we have one database, so that database is going to interact. So these steps, each step is going to interact with the database, required database, and it will pull out the required data or suited data as per the need of the component. So these two modules are going to interact with each other to identify the optimized process plan before going to the manufacturing. So the moment you identify the optimized manufacturing a computer-aided process planning, that computer-aided process planning is integrated with the computer-aided manufacturing process. So basically, you try to remember in the case of computer-aided process planning software consists of two modules. One is the different steps to be performed in CAPP, and on the back end you have the database from which we are going to pull out the required data to suit as per the needs of the manufacturing. So these are the functions of the computer aided process planning. There are two functions in the case of computer aided process plus. One is process planning, another one is to generate the reports. Obvious, every computer aided process planning needs to process plan. It may be a generative or it may be a variant approach. Using those two approaches, so we are going to generate the process plan. We are going to create the process plan as per the needs for the machining. The process planning should be able to edit, delete, then edit and delete the existing process plans in the case of variant approach. If it is a generate approach, it should be able to generate the new process plan, and it should be able to display all the process plans to the process planner to modify as per his needs. This is the one function of the computer-aided process plan. There are basically two functions for the process planning, computer-aided process planning. One is it should be able to generate the process plan. It should be able to generate the reports, which includes it should be able to identify the parts, identical parts. This CAPP should be able to identify the parts which are identical. It should be able to identify the specific machine type that needs to be used. It should be able to identify as well as record. This CAPP should be able to record the similar or identical components or the part families. It should be able to document the specific machine type that needs to be used during the machining process. This CAPP should be able to document or should be able to generate a report for the specific materials that that we need to take care while machining process. It should be able to document. Then it should be able to generate the bill of material. Bill of material means you have a component. In that case, you have a assembly. In that case, you have different items. The number of items in an assembly needs to be displayed, needs to be documented. It should be able to generate. That is also one of the function of the CAPP. The CAPP able to generate all the reports, which includes the identical parts, specific machine types, specific tool materials. It should be able to also generate a report of bill of materials. So this is the second functionality of CAPP. When it comes to the advantages of computer-aided process planning, obviously it is going to reduce the cost and lead times of the process plans when you compare with the conventional computer-aided conventional process planning process. In the case of conventional process planning process, experienced people are going to sit together. They will decide what process we need to follow, what mission we need to follow, what are the sequence of operations we need to perform before going to the manufacture. That is a conventional process. They will document everything. They will have some brainstorming sessions to optimize the process planning. But if it is computerized, it is going to reduce the cost of the process planning. In turn, it reduces the lead times of the process plans. Actual time required and the expected time required, the gap between actual and actual and as well as the expected time reduces. It reduces the need of skilled process planning. Of course, you don't require the skilled process planner. You don't require any expertized process planner in this case. Everything is performed by the process planner, computer, so that you don't require much skilled process planner in this case. It also going to decrease the process planning time. Yes, we are using computer. Definitely, it reduces the process planning time, decreases the cost of the process planning. Of course, it uses the, by utilizing the resources efficiently, accurate and consistent process plans we will get. There is no deviation from one process plan to the another process plan. There is some consistency in the process plans. Then you have productivity and process validation. It is going to enhance the productivity as well as the validation also. Validation accuracy also increases. Then you have it is going to maximize the just-in-time performance. JIT is one technology, one manufacturing system. In this case, it is aimed to reduce the reduce the manufacturing time as well as the suppliers and the customers response time. JIT is one manufacturing methodology to reduce the times of the production systems as well as the response time of the suppliers and customers. This is one technology or the methodology, reduce the manufacturing time as well as the response time of the customers and suppliers. When it comes to the disadvantages of the computer-aided process planning, we have some disadvantages. One is it is slow for the special manufacturing techniques. Suppose if we have any special manufacturing technique, in that case, it takes more time. That is what he's trying to say. It takes more time if we have any special manufacturing process or special manufacturing technique. The initial cost of establishing CAPP is high. Yes, once it is a one-time investment. Once you invest something on that, the advantages are more. But the initial investment is high if you want to implement CAPP or if you want to use CAPP. Then you also require professionally trained persons to use CAPP. To utilize CAPP, it is where we need to work on the systems, so that we require the trained professionals to use CAPP. So these are the disadvantages. It is slow in special manufacturing techniques. Initial investment is more. Then professionals or trained persons are required to work with CAPP. However, some extent, if you take unskilled operator also, they require some training to work with the CAPP. You have other, then we will see in the next slideshow, we will see the integrated CAD/CAM organization. We also see the necessity of CAD/CAM integration. Then we will see the benefits and advantages of integrated CAD/CAM organization. Then we will see the computer integrated production system, introduction to the computer integrated production system. In the next session, we will see these contents. In the next session, integration of CAD/CAM organization, integrated CAD/CAM organization. Then we will see the necessity of CAD/CAM integration. We will see the benefits and disadvantages or advantages with the integration of CAD/CAM, integrated CAD/CAM organization. Then we will see the computer integrated production system also in the next session. Thank you for this session. Thank you, one and all.